This is the 2-1A lesson on solving linear equations using models. It says, in the previous lessons, we studied linear expressions. That was module 1. When we set two linear expressions equal to each other, we've created a linear equation. A solution to an equation is a number that makes the equation true when substituted for the value. Algebra tiles can be used to solve linear equations. Number 1, examine the model or the tiles to the right and write an equation that the model represents. So the first thing we might notice is that now as we look at models, we're going to have this boundary line, which represents the equal sign. So you're taking notes on this, and feel free to pause the video if I'm going too fast to get caught up or rewind it. But we're going to first mark that or annotate that. And then next, we're going to build our equation. So everything on the left side of the equation is going to be on the left here. And we have 1, 2, 3, 4, 5 x tiles plus 1, 2, 3, 4, 5, 6, 7, 8 shaded unit tiles plus 2 shaded x tiles equals, and on the right side we have 1, 2, 3, 4 unit tiles that are positive. So there's our equation. The two sides, the left and the right side. Then on number 2, still the same problem, we're going to use tiles and we're going to model and solve the equation. We're going to eliminate zero pairs. We don't necessarily need to circle them. We're going to explain what we did, and then we're also going to start to practice doing this without algebra tiles. All right. We're going to start first with the algebra tiles, though. So here is, they redrew this for us. There's even the equal sign we talked about. In step 1, we're always going to be looking for cleanup or simplify. That can be done, and it has to be done on the same side. So for example, on the right side, this looks already done or simplified. But on the left, I'm noticing that there are some of these things. These are zero pairs. So I'm going to put for step 1, cancel zero pairs. All right, now I'm going to redraw what I have left over, which is 3 unshaded rods and 8 shaded unit tiles. We also have these. And notice how I'm not canceling those even though they are zero pairs because they're on opposite sides. All right, and now I'm stuck. And spoiler alert, the end of this, if I scroll all the way down, is my goal is I want to figure out how many unit tiles is an x tile equal to. 1 rod equals what? And so if my goal is to get 1 rod alone and they go up here, the first thing I want to do is get rid of these unit tiles. So what I'm going to do is I'm going to actually make some zero pairs to get rid of these. So if I draw or include 1 unshaded unit tile, that means I could cancel one of these, and I'm getting closer. But since there's 8 shaded, I'm going to draw 8 of these little pesky tiles. But in order to justify doing this, I have to do the same thing on the other side of the equation. So I'm going to draw 8. Notice how I kind of set them apart from the other one. So I make sure that I'm drawing 8 new ones on the left. And then to accommodate for that or be fair, I'm drawing 8 on the right as well. So step 2 is add 8 positive unit tiles to both sides of, I'll just put that for equation or equal sign, where you can write out the word equation. In the same step, step 3, we're going to do something called cancel zero pairs again. We made zero pairs since we were stuck. So we made these tiles appear so that all of these could go away and we were left with just the X tiles. So now we have these. We're getting closer to our end game. And on the right, we now have a lot of these. All right, looks like we have 12 unit tiles. Again, feel free to pause the video to get that down or go back. And the last thing that we need to do, so this would be step 4, is we need to justify or show how we're going from here to here. And what we're going to do is we're going to make some groups. We're going to make specifically 3 equal groups on both sides of the equation. 3 equal groups because we have 3 X tiles. So this number will always be based on how many of these there are. So if I have 3 and I want to get to 1, I'm going to make 3 groups. If I had 4 and I want to get to 1, I'm going to make 4 groups. If I had 5, I'd make 5 groups. And then 3 equal groups, meaning I'm going to go like this: 1, 2, 3. So each group has 1 rod in it. And on the right side, I'm going to make 3 equal groups. But to place an equal amount, I'm going to put 4 unit tiles in each group. So this time I have to circle these vertically. All right. And now the last step is that, and don't do this to your paper, but I'm just going to show you something. If we ignore those and we ignore these and we just look at the groups, like one set of groups, I can see that my answer is x equals 4. Step 5 is x equals 4. All right, but don't destroy all those. And I'll get rid of the yellow. Okay, now we're going to go back up to the top and we're going to solve this algebraically. So first step is we're going to copy down the original problem that was up at the top of our paper, which was this. All right, and it says, what did we do? We actually did something called, we canceled 0 pairs. We combine like terms. We combine these and we combine these. And we had 3x plus negative 8 equals 4. If we look at our paper at some point, we had 3x plus negative 8 equals 4. I'm also going to add a little boundary line here, all the way down to the bottom, just like we did for tiles. There was a boundary line. Okay. So now I have 3x plus negative 8 equals 4. I'm basically just redoing the same things. What did I do? I added positive 8 to both sides. Notice how I'm lining it up. I'm going to draw up my tally line. These cancel, and I'm left with 3x equals 4 plus 8 is 12. How do I know it's 12? Well, I can just count out my tiles. So it was 3x equals 12. And then we made 3 equal groups, which means we divided the tiles up. So we're going to divide both sides by 3. And we're left with 3 divided by 3 is 1x equals, and 12 divided by 3 is 4. Also known as just x equals 4. The last thing we're going to do, because there's one other part to this problem, believe it or not, is number 3. We're going to take the original problem, which was 5x plus negative 8 plus negative 2x equals 4. We're going to draw on that boundary line again. And we're going to take our answer. We got an answer of x equals 4. In every place where there is an x, we're going to plug this in and see if this checks out. This is called a verify or check. All right, so it's going to go like this. We're going to have a 5 times something plus negative 8 plus negative 2 times something equals 4. So in each of these spots, I'm going to plug in a 4. 5 times 4 is 20 plus negative 8 plus Negative 2 times 4 is negative 8. This 4 just keeps coming down. 20 plus negative 8 is 12, plus negative 8 equals 4. And 12 plus negative 8 is 4. We want to see that we get the same two numbers. It's just a coincidence that it's also the answer there. So that's what we're looking for, equal numbers. This might be one of the trickier parts, and we'll do it again on the upcoming ones. And this one is kind of weird that not only out of the gate is this a tricky concept, but the answer ended up also being the check number.